Its central idea was that atoms do not always behave like individual particles. Sometimes they merge together and behave like waves. They can also be particles and waves at the same time. Even for great minds like Albert Einstein, this strange paradox was hard to accept. In 1925, a young Indian physicist, Satyendra Bose, sent Einstein a paper he'd been unable to publish. Bose had attempted to apply the mathematics of how light particles behave to whole atoms. Einstein realized the importance of this concept and did some further calculations. He predicted that on reaching extremely low temperatures, just a hair above absolute zero, it might be possible to produce a new state of matter that followed quantum rules. It would not be a solid or liquid or gas. It was given a name almost as strange as its properties: a Bose-Einstein condensate. For the next 70 years, people could only dream about making such a condensate, which has never been seen in nature.
Matter can exist in various states. Atoms at high temperature always form gases. If you cool the gas, it becomes a liquid. If you cool the liquid, it becomes a solid. But under certain circumstances, if you cool atoms far enough to extremely low temperatures, they undergo a very strange transformation. They undergo an identity crisis. So let me show you what I mean by an identity crisis. When you go to low temperatures, the quantum mechanical properties of the atoms become important. These are very strange, very unfamiliar to us, but in fact, each one of these atoms starts to display wave-like properties. So instead of points like that, you have little wave packets like that moving around. It's really difficult for me to explain just why that is, but that's the way it is. Now, as you go to very low temperatures, the size of these packets gets longer and longer and longer. And then suddenly, if you get them cold enough, they start overlapping. And when they overlap, the system behaves not like individual particles, but particles which have lost their identity. They all think they're everywhere. This little wave packet over here can't tell whether it's this one or that one or that one or that one or that one. It's there and it's there and it's there. They're all in one great big quantum state. They're all overlapping. They're all doing the same thing. And what they're doing, to a good approximation, is they're simply sitting at rest. This Bose-Einstein condensate is very difficult to imagine or to visualize. I can imagine what it's like to be an atom running around gaily, freely, bouncing into things, sometimes going fast, sometimes going slow. But on the Bose condensate, I'm everywhere at once. I've lost my identity. I don't know who I am anymore. I'm at rest, and all the other atoms around at rest, but they're not other atoms around. We're all just one great big quantum system. There's nothing else like that in physics, and certainly not in human experience. So just to think about this causes me wonder and confusion.
All right. So kind of weird, huh? That's a weird video, and it's a weird state of matter. Let's take out our notes and define that one. That's okay, as long as you got something to write on, that's all that matters. So this is the Bose-Einstein condensate, named after the two men. One guy was Mr. Bose, one guy was Albert Einstein. Bose-Einstein condensate. And this one's super weird. Like the guy said in the video, you can't even imagine it. It's too weird to possibly imagine. But basically, what it is, in essence, is a very low energy state of matter. only possible at very low temperatures. All right. It was a very, what did I say? A very low energy state of matter, only possible at very low temperatures. Now, on the other side, we're going to go to plasma, which is the highest energy. This is our fifth and final state of matter.
Direct conversion kits that allow you to run gasoline, natural gas, or propane.
Hi, I'm Emerald Robinson, and in this What Is video, we're going to investigate the state of matter called plasma. Plasma is the state of matter that consists of a mass of free electrons and positively charged particles called cations mixed together. Plasma has neither a specific shape nor a consistent volume. In other words, plasma can easily flow into and take the shape of a container and will expand, redistributing itself to evenly fill that container. Although the properties of plasma are similar to those of gases, plasma and gases are not the same thing. In plasma, electrons are released from their orbits around a nucleus, creating a soup of free electrons and nuclei. Because these charged particles are loose, plasma easily conducts electricity and both produces and responds to magnetic fields. Plasma is created when a gas is either exposed to a high temperature or when high voltage electricity is passed through it. The heat or electricity makes the atoms in the gas move so quickly and collide so violently with one another that electrons are knocked from their orbits. Because of the way they are created, plasmas are sometimes called ionized gases. Although plasma isn't discussed as often as solids, liquids, and gases, and was the last phase of matter discovered, you're probably more familiar with plasma than you think. Plasma gives neon and fluorescent lights their glow, is formed during lightning strikes, and of course is present in plasma televisions. Chemists also classify fire as a plasma. Plasma makes up our sun and is visible in the solar flares that erupt from its surface. Because plasma is the stuff of stars, it is the most common state of matter, making up about 99% of the observable universe.
For thousands of how-to and advice videos on any topic, visit monkeyc.com.
Cool. So that's plasma. How should we define plasma? Let's call it a, here's plasma. Let's call it a very high energy state of matter. Oops. A very high energy state of matter. I'm having a hard time using the pen today. So when I turn on the fluorescent lights, when I'm finished writing these notes down, you will experience plasma. When the lights light up and turn that yellow glow, that's plasma. Same thing that's in lightning, same thing that's in the plasma TV. So just to summarize the 5 states of matter, in order of their relative energy. Yeah, let's go from lowest to highest. Let's have a little energy diagram here. Let's go high energy up there. Let's go low energy down here. What's the highest one? Plasma. Yeah. What's a little bit lower than plasma? Gas. Uh-huh. And then lower than that? Liquid. And then lower than that? Solid, yeah. And then what's the lowest possible? The Bose-Einstein. I'll just write BE. We don't need to write out that whole thing. B.E, Bose-Einstein. All right, any questions? All right, let's do a little review. Looks like a couple people are still writing, so I'll wait a second.
For test, do you have a study guide, or do you have to study on your own?
I will give you some study materials, yeah. I will definitely tell you what's on it. All right, for example, this is a review. This is something that I would put on the test. Actually, I'm telling you for a fact it is on the test. I'm going to give you some of these pictures, and I'm going to ask you element, compound, and mixture. So let's do some practice here. Let me get my Jolly Ranchers. Wake us up a little bit on this Monday morning. So as you take a look at it, you can look back in your notes the difference between element, compound, and mixtures if you forgot, or if you just want to refresh your memory. And then take a look up at what's at the board and see what you think. These are drawings of molecules. Suzanne, what do you think?
I think it's a mixture
She thinks it's a mixture.
or a compound because there's two like different ones.
So what do we have going on here? We got different things in each little packet, but then we got multiple of the same packets. What do you think, Wilbur? Why do you think it's a compound? Louder? Wilbur, louder? Yeah, say it louder. What'd you say? You're right. Say it again. Two different what? Elements. Two different elements. Now let me explain a little bit. So each of these things is a molecule. Let me get out my pen so I can show you. The whole thing is a molecule. But within each molecule, there's two different things. The little black guy could be, I don't know, oxygen. And the little white guy could be hydrogen. It could be water, H2O. So you have two different elements, two distinct elements bonded together, and then the same of that. So that's how you know it's a compound, because two or more elements are bound together. Any questions on that? How about this one? Logan, what you think? And why do you think it's a mixture? You can see the different components. You got some black molecules flying around, you got some white molecules flying around. It's a mixture. It's not a compound because there's no two bound together. And it's not an element because there's more than one different type. All right? Jared, you got a question?
I'm just waiting for the next one.
Jared's getting excited waiting for the next one. Jared, what do you think?
Elements.
Element. And how do you know it's an element?
Because breaking down.
It's only one molecule.
It's only one thing. Yeah. What if these guys were bound together? What if instead of just individual things like that, it was, what if instead of just one, it was two of these little black dots stuck together? You see how I'm drawing that?
Yeah.
If it was two of these, what would that be? It would still be an element.
Because it has
Even though it's two bound together. Let me draw a couple more just so everyone is clear on what I'm doing. I'm making these guys coupled up here. Even if they're coupled up, it would still be an element. because a compound needs to be two or more distinct elements. If it's two of the same, it's still an element. You got to have different ones in order to get to be a compound. Check this one out. What you think? I hear compound. And she's right. It's a compound. Because we got two or more elements bound together, and then just a bunch of those. Compound. Very good. How about this one? Courtney, what you think? Courtney says compound. Anthony, what you think?
Mixture?
Mixture. And why is that a mixture?
Because, like, we got, I'm going to see this. We got, like, compounds, and, like, you got elements, molecules, like, different molecules.
A mixture is different things, different components. Here we go. There's one guy, and there's another guy. Now, Courtney, you're right that this is a compound, and this is a compound, but the whole thing together is a mixture. Hmm? How about that one? Carly, what you think? Carly says mixture. She's right. We got elements and compounds in there. Very good. And how about this one? I think this might be the last one. Who haven't I heard from yet? Keep your hand up if you didn't get it, if you did not get a candy yet. Gigi, what you think? She thinks it's a compound, and she's right. We got two or more elements bound together. Very good. I got what? Oh, I'm sorry. Am I being unfair? I got to start standing over here more. That brings us to our final section, guys. We got one more thing to talk about, and then that'll be it for the first chapter. Okay? Let me see if I can go to camera mode.
Why don't you never write on the board?
Yeah. Actually, hold on. Wait. Can you wait till we're done with the notes? It won't be long. The reason I don't write on the board is because I want everything to be saved online for the people who have to miss class.
That's going to be online too? Are you videotaping the class today?
This is not going to be online. Only the things that are on the computer will go online. Actually, I should stop this. Thank you.